So here we are trying to find how fast prices will double if price inflation is increasing by 4% compounded annually. So in order to get prices to compound annually, we have to use this formula for compound interest. Since prices are increasing, we use the plus sign here. So how soon will it take for prices to double means that we need to set this equation equal to 2p. So we're looking for how long it'll take the principal amount to double. So that's 2 times p. So after we have it set up, we will state what we know. We know that R is 0.04. We get that by taking 4% and dividing it by 100. This is our rate, R. We know that M equals 1 because it's compounded annually, meaning it's compounded once per year. How soon lets us know that we're looking for T. We don't know T. That's what we want to find out by working this problem. So taking all of that information and substituting it into our formula, we end up with this. And there's some simplifying that we can do inside the parentheses here. So first we will simplify 0.04 divided by 1. 0.04 divided by 1 is just 0.04. Then we'll add 0.04 to 1. And when we do that, we get 1.04. From here, it's time to divide both sides by p because we can only solve for one variable in an equation at a time. We got to get rid of one of our variables. We can easily get rid of p by dividing p on both sides. So what we're left with is 2 equals 1.04 raised to the power of t. And in order to solve for t, we have to use logarithms. So our next step is to take the logarithm of both sides using a natural log. So when we do that, we can move the exponent down to the front as a product, as I've done here. So now that we have t times the natural log of 1.04, I can divide both sides by the natural log of 1.04 on the right-hand side in order to get t by itself, which is what we want. We want to solve for t. So putting in your calculator the natural log of 2 divided by the natural log of 1.04, we get t is approximately 17.7 years. And to do that, the way that I have to type it in my calculator is like this. The natural log button, then the number 2, then I have to close the parenthesis for a natural log, then the division symbol, then the natural log of 1.04, entered in next, close the parenthesis, and then you should get approximately 17.7 after hitting enter. So for part B, we want to know how soon will prices triple. So instead of multiplying principal times 2, as in the previous problem, to get the principal to double, now we're trying to get the principal to triple. So instead of 2, I have a 3 multiplied times p, because to triple something means to multiply it times 3. We're using the same rate and the same number of periods per year as we did for part A. And again, we're looking for t. So filling everything in to this formula, everything is the same from the last example until we get to this side over here where we've substituted a 3 instead of a 2. So we follow the exact same steps as we did for the previous problem. And then when we get ready to take the natural log of both sides right here, we will then write this as a product. We can put the t in the front as a product. And then we're ready to divide both sides by the natural log of 1.04 again. Only this time we're dividing the natural log of 3 by the natural log of 1.04. So I'll write again how to type that into the calculator. You get the natural log button, put in 3, close your parenthesis, divided by the natural log of 1.04, close your parenthesis. When you do that, you get t is approximately 28.0 years. So according to our findings, it's going to take approximately 17.7 years for the price to double with a 4% inflation, and it's going to take approximately 28 years for prices to triple with a 4% inflation on